Series means addition of the sequence, arithmetic sequence. We need to find out the numbers which are divisible by 13. That means we need to add those numbers only between 60 and 400 which are divisible by 13. Sequence is nothing but an orderly arrangement of number which will have some property related to it. The number and its preceding term will have a constant, and that is denoted by D, and it is called as common difference. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to take up the new chapter, progressions. So here in this session, we are going to study about different types of progression and evaluation of the problems related to it. In this session, we will discuss the weightage of the chapter progression and the topics for the session and the problems related to it. So from this chapter, you will get 3 questions in MCQ that may be in the form of an objective type. Either it may be in the multiple choice question, fill in the blanks, match the following, or one word answer. Then under short answer, you will be having 1 question for 2 marks and long answer 1 question for 3 marks, essay type 1 question for 4 marks. So overall, in total, there will be 6 questions which carries 12 marks in this chapter. Now in this session, we will be discussing what do you mean by sequence and the series, and the first type of progression, that is the arithmetic progression. Now what do you mean by sequence? A sequence is an orderly arrangement of a number according to some rule. For example, if I write 2, 4, 6, 8, form a sequence, it's a sequence of even number. Now if I write 1, 3, 5, 7, 9, it's a sequence of an odd number. And if I take 2, 3, 5, 7, then it's a sequence of prime number. So sequence is nothing but an orderly arrangement of number which will have some property related to it. Now in sequence, we have finite as well as infinite sequence. And a sequence having finite number of terms is called as finite sequence. Terms are nothing but it may be any variable or a number. So if it is finite, as we have studied finite set, in the same way it is called as finite sequence. If it is an infinite, then it is called as an infinite sequence. That means which is not countable. Next, series. The sum of the terms of the sequence is called the series of the corresponding sequence. Now if I consider 1, 2, 3, 4, 5 as a sequence, then the sum of all those number 1 plus 2 plus 3 plus 4 plus 5 will form a series. So series nothing but a sum of a particular sequence. And here also we will have a finite as well as infinite series. A series having a finite number of terms is an infinite series, whereas the series having an infinite number of terms is an infinite series. So infinite series is an example here, 4 plus 5 plus 6 plus 7, etc. And here we have taken a sum from 1 to 10. So here the numbers are finite. So therefore the sequence as well as the series is finite. Now let's discuss the very first type of a sequence called as arithmetic progression. Now what do you mean by arithmetic progression? It is shortly defined as AP. Now an arithmetic progression is a sequence. It is a sequence in which the difference between a term and its preceding term is a constant. Now if you take A1, A2, A3 as a sequence, the difference between A2 minus A1 will be same as A3 minus A2. So the number and its preceding term will have a constant, and that is denoted by D, and it is called as common difference. Now here I have taken an example of 1, 3, 5, 7. It's a sequence of odd number. We can clearly see there is a difference of 2 here, and the first term is always 1 here and 2 is the common difference here. Generally we denote the first term by A and the common difference by D. So using this series, we can write the nth term of an AP using the formula Tn is equal to A plus n minus 1 into D. Here n represents the position of the number. If I say T3, then it denotes the third term. If I say 10 as n, then it denotes the 10th term. So here A is called the first term, n is the number of terms, and D is the common difference. The general form of an AP can always be expressed in the form of A plus D, A plus 2D, etc. and the last term as A plus n minus 1 into D. So this is the arrangement of a sequence of an AP. Now if we add this, we'll get the series. So that is the sum of n terms of an AP. That is called as arithmetic series. So series means addition of the sequence, arithmetic sequence. Now that is given by the formula Sn is equal to n by 2, 2a plus n minus 1 into d, where n is the number of term, a is the first term in the sequence, and d is the common difference in the sequence. Now let's take few problems. Find the 12th term of an AP 147. So by observing the sequence here, we can write the value of A is 1, the value of D is 3. You can see 4 minus 1 is 3, 7 minus 4 is 3. So therefore the common difference is 3. We need to find out the 12th term. That means we need to find T12. So when I say T12, n is given as 12. So if we want T12, then using the formula a plus n minus 1 into d, we can write it as a plus 11d. So anything, for example, if we need T1, then it is a. If we need T2, then it is a plus d. T3, it is a plus 2d. T4, it is a plus 3d, like this. So the last term will be n minus 1 into d, depending upon the number. So now T12 is equal to a plus 11d. So T12 is equal to 1 plus 11 into 3, so 1 plus 33, which is equal to 34. So the 12th term of this sequence is 34. Next, find the sum of the arithmetic progression 2, 6, 10, etc. up to 10 terms. So the last term is 10. That means they have given the number of terms as 10. Now let's check the first number, that is 2, and the common difference between them is 4. 6 minus 2, 10 minus 6 is 4. So now we need to find out the sum of arithmetic progression. That means we need to find out the arithmetic series Sn, which is given by n by 2, 2a plus n minus 1 into d. We doesn't know the numbers there, but we have to find out until the 10th term. So therefore S10 will be equal to 10 by 2. 2 into a means 2 2s are 4 plus 10 minus 1 is 9. So 9 into 4. Now 2 1s are 2 5s are 5, 4 plus 36. So which is 40. So 200. So 40 into 5 will becomes 200. Next question. If the second term of an AP is 4 and the 10th term is 20, find the 15th term. So they have given T2. So what is this T2? It is 4. And also they have given T10, which is equal to 20. We need to find out T15. Now T2 can be written as A plus D, which is equal to 4. T10 can be written as A plus 9D, which is equal to 20. Now let's use this equation. So A plus D is equal to 4. Let us subtract them. This get cancels. Now AD is equal to 16. D is equal to 2. So we got the common difference as 2. Let me substitute here. That is D is equal to 2. Then T4 A is equal to 2. So we got A is equal to 2. D is equal to 2. Now T15 can be written as A plus 14D. So therefore this is 2 plus 14 into 2. So 2 plus 28, which is equal to 30. So therefore the 15th term is 30. Next, how many terms of the AP 2, 3, 4, 5, 6 amount to 230? So we don't know how many terms are there in the sequence, but they have given the sum of the sequence as 230. So that means we need to find out the value of n. So we know that Sn is equal to n by 2, 2a plus n minus 1 into d. So that is equal to 230. So now let us make a substitution for a and d. Let n be here 2. 2a means the very first term is 2. So a is 2. 2 2s are 4 plus n minus 1. The common difference you can see is 1 is equal to 230. Now let me keep n here. So we have 4 plus n minus 1 here. I'll multiply 2 towards this side. Then this is 460. Now here we have 4 minus 1, 3. So we have n plus 3 is equal to 460. Now we have n square plus 3n minus 460 is equal to 0. Now this can be written as n square plus 23n minus 20n minus 460 is equal to 0. If we solve this, we'll get n is equal to minus 23 or n is equal to 20. Now since the number of terms cannot be negative, so n is equal to minus 23 is not possible. So therefore, the value of n is equal to 20. That means 20 terms sum up to the amount 230. Next, the sum of three numbers in an AP is 15 and their product is 105. Find the numbers. Now since arithmetic progression is given in the form a plus d, a plus 2d, etc. So I'll take the previous term of a as a minus d and I'll consider these three numbers as the first three numbers because for the calculation it will be more simpler than these three terms. So let the terms be a minus d, a and a plus d. Now given the sum of three numbers, that means the sum of these three numbers a minus d plus a plus d, that is equal to 15 and their product is 105, that is a minus d into a plus d is equal to 105. So let us solve them. We can cancel minus d and plus d here. We'll get 3a is equal to 15. So a is equal to 5. Now using that equation here, a minus d, a plus d can be written as a square minus d square. And here we have a which is equal to 105. Now a value is 5. So 25 minus d square is equal to 105. Now 25 minus d square is equal to 21. So now here we have d square is equal to 25 minus 21 which is equal to 4. So d is equal to plus or minus 2. Because it is a square root of 4, it can be plus 2 or minus 2. Now here if we consider a is equal to 5 and d is equal to 2, then AP will be 5 plus 2 7, 7 plus 2 9. Now if we consider a is equal to 5 and d is equal to minus 2, then AP will be 5 minus 2 3, 3 minus 2 1, etc. So this is the required answer. Next, find the four numbers in AP whose sum is 20 and the product of whose extremes is 16. Again, here in the previous problem we have taken a minus d, a plus d. In that form we have to take the four numbers. So let the numbers be a minus 3d, comma a minus d, comma a plus d, comma a plus 3d. So given that the four numbers sum is 20 and product of extremes is 16. So these are the extremes. So let's take the sum here. A minus 3d plus a minus d plus a plus d plus a plus 3d is equal to 20. Now plus 3d minus 3d plus d minus d get cancels. We have 4a is equal to 20. So a is equal to 5. Now here the product of the extremes, that is a minus 3d into a plus 3d is given as 16. So which will be in the form of a square minus 9d square is equal to 16. Now let's take a square here. So a square is 5 square. 25 minus 9d square is equal to 16. So we will get 9d square is equal to 25 minus 16 which is equal to 9 again. Now d square is equal to 1 or d is equal to plus or minus 1. Again here by taking a is equal to 5 and d is equal to 1, the AP is 5, 6, 7, etc. If we take a is equal to 5 and d is equal to minus 1, then AP is 5, 4, 3, 2, etc. So we can also write the next number since we require 4 number here. So this is 5, 6, 7, 9. And if we take these in the form of -1, then we can write this as 5, 4, 3, 2, etc. Next, find the sum of all integers between 60 and 400 which are divisible by 13. So here the first and the last term is given, but they have given integers between 60 and 400. We need to find out the numbers which are divisible by 13. That means we need to add those numbers only between 60 and 400 which are divisible by 13. So here, let's write the numbers between 60 and 400 which are divisible by 13. So if we write the numbers between 60 and 400, we have 65, next we have 78, etc. The last number will be 390. Now, here the common difference between each term is 13. So clearly I can take A is equal to 65 and D is equal to 13. And here the last term is given, that is nth term is given. So that is equal to 390. Since we are supposed to find here, we have one more formula, that is Sn, when you know the first and last term. So this is A and this is L. So it is given by n by 2 into A plus L. So this is how we will find out the sum of the sequence when you know the first and the last term. We can use this formula. So we have n by 2. So we don't know number of terms here. So that number of terms can be calculating using Tn. So the last term can also be considered as Tn. So they have given the last term Tn as 390. Now n we don't know, we need to find out. But we know the formula. A plus n minus 1 into D is equal to 390. So now A is given 65, n minus 1, D is 13 because the common difference between them is 13. Now here we have n minus 1 into 13 is equal to 390 minus 65, which will be 325. So then when you divide this by 13, this is equal to 25 and n will be equal to 25 plus 1, 26. So the value of n is 26 here. So we can substitute here 26 divided by 2. That means there are 26 numbers between 60 to 400 which are divisible by 13. So the first term is 65 and the last term is 390. So evaluating this, we will get 13 into 455. That is equal to 5,915. So you can use this as one more important formula if you know the first and last term of an arithmetic sequence. So in today's session, we have discussed how to find out the nth term as well as the sum of n terms of an arithmetic progression. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.